Oh, my bad. All right, guys, welcome back. Unit 3, Worksheet 8, answers. This is on arithmetic sequences. So, first 3 questions. Determine whether the sequence is arithmetic or not. If so, find a common difference. Boom, there we go. If it is arithmetic, then there is a common difference, meaning we are adding the same thing from term to term. Plus 6, plus 6, plus 6. Guess what? Common difference is 6, so that's a yes. This is arithmetic, okay? Oh, that's a small eraser. That's a bigger one, okay? Question 2. From 2.1 to 1.4, so subtract 0.7. Subtract 0.7, subtract 0.7, yes. Also arithmetic because we have a common difference. We do not say subtract 0.7. We are saying we're adding a negative 0.7, okay? So our common difference is always what would we add to it. So that would be a negative 0.7 in this case. All right, negative 1, 10, negative 100, 1,000. It looks like we are multiplying by negative 10 to get from term to term. That is not a common difference, so no, it is not arithmetic. In fact, in a couple units later from now, we will discuss geometric sequences, which is what that is, when we have a common multiplier or common ratio, okay? So, but this is not arithmetic because we did not add the same thing every time. Okay, so question 4. State the common difference for each arithmetic sequence. Looks like we are subtracting 3, subtracting 3, subtracting 3. So, arithmetic is adding a negative 3. From 1/2, ooh, I don't like that there's different fractions there. Let's rewrite that as 2/4, 3/4, 1, this number right there, 1. Oh, that's really 4/4. Next one is 5/4. Okay, now it becomes much clearer to see. Go from 2/4 to 3/4 to 4/4 to 5/4. We're adding 1/4 every time. Okay? This worksheet might be quicker. This might be my quickest video yet. Okay, write out the next 4 terms of each arithmetic sequences. Okay, add 7, add 7, add 7 gets me to 526, then 533. Dang, I did not give myself enough space on these blanks. 540. Ooh, that's an ugly number. 547. Boom. Let's double check my math. 7, 7, 7, 7, 7, 7, 7. Got a really good joke from Friends right now, but that would not be school appropriate. Here we go. Subtract 5, or I guess we could be saying add negative 5, add negative 5, add negative 5, add negative 5. Boom. Okay, first 7 answers. There we go. Now we are writing the recursive rule. Remember, the recursive rule consists of 2 things. Stating the first term, followed by stating what every term thereafter becomes. an plus 1 means the very next term is always going to be, what are we doing? We are adding 10, so d equals 10. Add 10 every single time. So what this means is our previous term, or our current term, plus 10. So this is our recursive rule. The way that we read this is our first term is 10. The next term is always 10 more than the term that we're on. So add 10 to each term ensuingly. Okay? Once again, we state our first term is 2. Looks like it goes up by 5, up by 5. So an plus 1 is, that just means that's a subscript of 1. That just means the next term is current term plus 5. Okay? This one is also adding 5 every time, but it starts at a different first term. First term is 1 instead of 2. Okay? But the rule for what happens for every ensuing term is just add 5. Okay? And again, for each of these formulas, you must state the first term, or else you are not telling us where we're going. Okay? Add 4, add 4, add 4. Okay, so first term is negative 5. Add 4 for each term thereafter. Boom. So pretty self-explanatory so far. Dang, we are rushing through these. Okay. And if this is too fast for you, press pause. And then that should hopefully give you a little bit more time. this is just a video showing you the answers step by step, not necessarily trying to teach you everything. We'll have our teachers for that. Write the recursive rule for an arithmetic sequence. Ooh, well, they already tell us what the first term is, so that helps us. Okay, they already tell us the first rule. Oh, dang, hold on one second. My computer's about to die. I need to plug it in. Don't want to have to redo this video. Because I'll lose all this crap if the battery dies in the middle of the video. Saved by the notification. Okay, here we go. So they already tell us the first term is -20. And they tell us what the fourth term is. You know what? I don't really know how I'm going to do this. Maybe I'll just draw a box to signify that as the first term. Don't know the second term. Don't know the third term. I know the fourth term. Okay? So we want to go basically from the first term to the fourth term. Okay? So to go from here to here, we would have to have added our common difference. We don't know what this is, but then we would have to add our common difference again. And we would have to add our common difference for a third time. So in reality, okay, we have to start at -20 and add 3 times our common difference to get us to 10. Stay with me. That is called an equation. And there's one variable there, meaning we can solve that equation. Add 20. And we get 3d equals 30. Oh, d equals 10. And you know what? I bet you if I fill this out now, adding 10, oh, looky here. Add 10, I get to -10. Add 10, I get to 0. Add 10, I get to +10. Look at there. My common difference worked. Now I can finish my recursive rule by saying an plus 1 is my current term plus 10. Because it is my common difference that I'm adding every time. Boom, followed by shaka, followed by laka. All right, write the recursive rule for an arithmetic sequence with a ooh. So this is our fourth term, fifth term, sixth term. Fourth term is 17, sixth term is 21. I'm going to do the same exact process. Add our common difference, add our common difference again. So 17 plus 2 sets of our common difference gives us 21. So 2 times our common difference is, when I subtract 17 from 21, I get 4. The common difference is 2. Let's check if that works. Add 2 gets me to 19, add 2 more gets me to 21. Hey, we need to find our first term. A1 equals something. Well, let's backtrack it. Our third term would be 15. Our second term would be 13, and our first term of A1 equal 11. Let's double check that. A1, A2, A3, A4. Starts at 11, add 2, add 2, add 2. There we go. Very quick, easy, painless way to find that our first term is 11. A1 equals 11. We already said our common difference was 2. AN plus 1 equals AN plus 2. Only one more answer video to make. Peace, peace.